Okay, welcome back. In the previous video, we learned how to swap weapons. So now we have the ability to walk up to a weapon and use the E key to swap it out and throw down our previously equipped weapon. Now in this video, we're going to add a little bit more to this functionality. Now let's take a look at an example of what we'd like to see. Now in this project, as I hit the E key to pick up this weapon, watch as it flies up in front of the camera. So it was really quick, but if you look closely, you can see that the weapon flies up to the camera, hovers for a second, and then it falls straight down. So this is the type of behavior that we would like to implement. As soon as we go to pick up a weapon, we want it to fly up in front of the screen just to show us what it is that we're picking up and equipping. And so in this video, we're going to talk about the theory behind how to make that happen. Okay, so in this video, we're going to discuss the item interping state for our items. Now, this is going to involve a couple of different parts. One of the parts involves interpolating the X and Y position of the item, and the other part involves using a curve to set the Z position of the item. So let's go ahead and discuss this and see what it is that we mean. Now, whenever we pick up an item, we saw in the video that the item flew up and for a brief moment hovered in front of the camera. So if we think about it this way, the character is about to pick up an item in the world, and as soon as the E key is pressed, then that item enters the interping state, at which point it begins to move. So it starts off at an initial location in the world, and it has a target location which is right in front of the camera. Now we would like this item to move along a curved path in space. Now this means we're going to have a target location which will have its own X, Y, and Z coordinates. And the item starts off with its own initial coordinates. Now, when we start this interping state, we would like the item to move along this curve. And so at any frame, it's going to have its current X, Y, Z coordinates changing as it moves along the curve and gets closer and closer to the target until eventually it reaches the target and its current XYZ are the XYZ of the target. Now, let's think about this in only the X and Y coordinates for a moment. And let's ignore the Z direction. So if we only wanted to take care of the X and Y coordinates, what we can do is we'll think of it as the item having its own initial location in space, and each frame it will have its own X and Y coordinates. And the target location will have its own X and Y coordinates. And so our item in the X and Y plane is going to move in a straight line toward the target. So as we're in the interping state, each frame we're going to update the X and Y location until that item eventually reaches the target XY. For this problem, we can use linear interpolation. Linear interpolation takes a current value. In this case, it could be the X and Y values for the object's location in space. And each frame, it moves the current value toward the target value, and the amount that it moves the current value towards the target value depends on the interpolation speed, or simply the interp speed. The higher the value of the interp speed, the closer the interpolation function moves the current value toward the target value any given frame. So in the XY plane, each frame we're going to use the interpolation function, and we're going to take the current location of the object using its X and Y values, and we're going to take a target position which has its X and Y values, and we're going to call the interpolation function, passing in a particular interp speed that's going to smoothly move our current location to the target location, resulting in the item smoothly floating toward the target position. But we also want the item to move in the Z direction as well. And in the Z direction, we don't exactly have a linear path to follow. It's more of a curve. So in this case, when our item enters the interping state, it's going to have a current XYZ and a target XYZ. In every frame, it's going to be moving along this curved path. So let's take a look at how we're going to manipulate the Z coordinate of our item's position. Here's a curve where the vertical axis represents our item's Z position in space, and the horizontal axis represents time. So as time passes by, our item's Z position is going to change according to this curve. So as soon as our item enters the interp state, it's going to have its initial Z position, indicated by the red dot on the graph. And as time continues to pass, our item's Z position is going to increase according to this curve until it finally reaches the very highest point that it's going to reach, at which point it's going to start coming down. And it'll reach this point here where it sort of hovers in the air for a little bit before finally dropping back down and eventually falling off the screen. In Unreal Engine, we can create curves like this that we can then use to drive our Z position in the world. So if we're using a curve to control the item's Z location, then as soon as we start interping, it's going to follow that curve, meaning it will fly up and hover at a particular Z value before falling back down like this. So that's what it's going to look like. Now let's talk a little bit about how curves can behave like a function of time. Let's say that we have a curve. Now a curve behaves like a function in that it can take a time as input and it will return to us a particular value corresponding to that time on the curve. Let's look at an example. Now let's say that we've got a timer going and we're 0.2 seconds into the timer. So 0.2 seconds have passed and we'd like to get a value from the curve for that point in time, 0.2 seconds. Well, if we look at our curve graph here, 0.2 seconds corresponds to this point on the curve, which has a value of 1 on the vertical axis. So if we take our curve and we pass in 0.2 seconds for the time, our curve is going to return us a value of 1. Let's say that we're 0.4 seconds into our timer and we'd like a value from our curve for this point in time. Well, likewise, we'll pass in 0.4 seconds to our curve and our curve will return us the value on the curve for 0.4 seconds, which according to our graph is 1.2. So curves behave like functions in that they take an input, which is a time, and they return some value that corresponds to that point on the curve at that point in time. So we're going to implement the interp state for our items. Let's discuss how this is going to work in code. Now in our game, our character is going to be walking around, and as soon as we're within a close enough range of an item, our character can start line tracing, and if we're hitting the item with our line trace, then we have access to the item. So when we hit our E key, then we can start performing actions. As soon as we hit the E key while we're line tracing and hitting the item, we're going to want to start a timer on the item. So on our item class, we're going to have our timer started, and we're going to need a way to know that we're in the interping state. For example, we can have a Boolean set to true. We also are going to start updating our item location. Remember, we want it to fly up into the air and hover before the camera just for a moment. So we're going to be updating it every frame. Now we're going to be updating that item's Z location according to the values provided to us from our curve. Now this item updating will happen until the timer is completed. Once the timer's done, then we can send that information back to the character. So we can call some function on the character telling it to go ahead and get the item. So if the item is a weapon, then the character can equip that weapon. Or if the item is a consumable like ammunition or something of that sort, well then the character can consume it and update its variables accordingly. So there's going to be some communication between the character and the item class. So we can go ahead and set up some of these relationships in the code in the next video.